Hello, and welcome back to Midnight Fact, where we unravel the fascinating mysteries of our world. Tonight, we're turning our attention inward, to a unique identifier that each of us carries, yet rarely truly understands: our fingerprints. Since birth, these intricate patterns on our fingertips have been a cornerstone of identity, forensics, and even our modern phone security. But have you ever stopped and wondered why no two fingerprints are ever alike? What scientific and biological processes guarantee this astounding individuality? Join me as we explore the remarkable story behind the uniqueness of your very own fingerprint. 2. Truly understand why your fingerprints are unique, we first need to appreciate what they are. A fingerprint is essentially an impression of the friction ridges found on the surface of your fingers. These aren't just random lines, they are complex patterns of raised skin, interspersed with furrows. Their main job is practical: to enhance our grip and our sense of touch. They allow us to grasp objects more securely and feel textures more finely. But their most profound characteristic, the one that has captivated scientists and law enforcement for centuries, is their absolute individuality. The journey of your fingerprint begins surprisingly early, between the 10th and 17th weeks of gestation, when you were still in the womb. During this crucial period, the basal layer of your epidermis, the outermost layer of skin, starts growing faster than the layer beneath it, the dermis. This difference in growth rates causes the top layer to buckle and fold, creating the characteristic ridges and valleys we see. Now, here's where it gets truly fascinating. You might think this process is all mapped out by your genes, but it's not. While your DNA does play a role in the general pattern types like loops, arches, and whorls, it doesn't dictate the tiny, specific details. Instead, the precise formation of your ridges is influenced by a multitude of incredibly subtle, chaotic, and random factors inside the womb. Think of it like a miniature, ever-changing ecosystem. The exact pressure exerted by the amniotic fluid, the rate of growth of different parts of your finger, your precise position in the womb at any given moment, and even the subtle growth of nerves and bones all contribute to the final pattern. It's like trying to replicate the exact flow of water in a river. Even the tiniest variables will lead to a slightly different path. The same principle applies here. These micro-environmental forces create unique stresses and strains on your developing skin, resulting in an infinitely varied landscape of ridges and furrows. This is precisely why even identical twins, who share the exact same DNA, have different fingerprints. Their genetic blueprint might guide the general shape of their hands, but those microscopic forces in the womb ensure their friction ridge patterns diverge. It's a beautiful example of how nature introduces randomness to create uniqueness. Forensic science has a term for the fine details within these ridge patterns: minutiae. These are the specific points where a ridge might end abruptly. That's a ridge ending or split into two, which is called a bifurcation. There are also islands, spurs, and bridges. It is the unique combination, sequence, and spatial relationship of these minutiae that truly give each fingerprint its individuality. A typical human fingerprint can contain anywhere from 80 to 150 different minutiae points. The probability of two fingerprints sharing even a small number of identical minutiae in the exact same configuration is astronomically low. Statistically, the odds of two people having identical fingerprints are estimated to be around 1 in 64 billion. To put that in perspective, that makes it virtually impossible to find two exact matches among all humans who have ever lived. Your fingerprint is, for all intents and purposes, completely unique to you, beyond their initial formation. Another crucial aspect of fingerprint uniqueness is their permanence. Once formed in the womb, these ridge patterns are remarkably stable throughout a person's entire life, from infancy to old age. The pattern you develop before birth is the pattern you will carry with you until the very end. While superficial cuts or scrapes might temporarily alter the outermost layer of skin, the underlying structure of the friction ridges, which is anchored in the dermis, remains intact. The skin just grows back in the same pattern. Even deep scars, which can permanently alter a fingerprint, simply become a new, unique identifying feature themselves. This permanence is what makes fingerprints such a reliable form of identification over time. The science of fingerprints, known as dermatoglyphics, continues to be a rich area of study. While their role in forensics and security is well established, researchers are still exploring potential links between certain fingerprint patterns and some genetic conditions. Though these remain areas of ongoing investigation rather than definitive diagnostic tools, what remains undisputed is the incredible biological marvel that ensures each one of us is imprinted with a truly personal and distinct signature. So, the next time you unlock your phone or just look at your fingertips, remember that you're not just seeing simple lines. You are observing the culmination of a unique developmental journey, a chaotic dance of cellular growth and environmental pressures that conspired to create an unparalleled pattern. It's a testament to the boundless diversity and intricate design embedded within nature, a tiny, yet profound, reminder of your individual uniqueness. Thank you for joining me on this exploration into the world within our hands. If you found this fascinating, please hit that like button, subscribe to Midnight Fact, and ring the bell so you don't miss our next journey into the unknown. Until next time, stay curious.